Welcome to the lecture. So in this lecture we will discuss about the closures. So closures are one of the important topic in JavaScript. Now let's take a look about closures. Now let's start by creating a new function that is const secure booking that is equal function. Now in this function we will create the closure. So now the first thing I need to tell you about closures is that a closure is not a feature that we explicitly use. So we don't create closures manually like we create a new function or new array. So closures simply happens in certain situations. We just need to recognize those situations. So here in this example, what we are going to do is we will create one of those situations so that we can take a look at closures. Let's continue writing. Let's write here giving let passenger count, that is I'm starting here with 0, but we will manipulate it again. So I am calling the secure booking function because pass count variable cannot be manipulated and accessed from the outside. So let's write here return function. Now, what's the special about this function is that it will return a new function. Now, this function is to update the passenger count variable. So, that is passenger count plus plus. So, the variable that is undefined in the parent function. So, this is the parent function that is undefined. So, now let's log this into console. Let's write here console.log using the literals. Then here write passenger count and also the passengers. So here we need to write the return in the function. Close here. Now let's call the secure booking function and then store the result in a variable called booker. For that let's write const. I'm giving here booker that is equal calling the secure booking function. And so this is similar to the function return other function. We have one function that we call and this function will return the new function. And so here we call secure booking. It will return exactly this function and is stored in this booker, that is stored in this booker. Now this is going to be a new function. Let's analyze what happens when this line of code is executed. So this is exactly the code what we wrote just now. Before we start running the secure booking function, here our code is running in the global execution context and in there we currently only have this secure booking function, and so we can also say that the global scope now contains secure booking. Then when secure booking is actually executed, a new execution context is put on the top of the execution stack. Now remember, each execution context has a variable environment which contains all its local variables. In this case here, it contains only the passenger count set to 0. This variable environment is also the scope of this function. And so the scope chain of this execution context looks like this. So passenger count is in the local scope, but of course this scope also gets access to all variables. So the parent scopes and in this case just a global scope. Anyway, in the next line of the secure booking function, a new function is returned and it will be stored in the booker variable. So the global context now also contains the booker variable. Alright, now what else happens when the secure booking function returns that its execution context pops off the stack and disappears. So the secure booking function has done its job and has now finished execution. Now it's very important to note that it's only the execution context itself that is gone from your stop. So the variable environment containing passenger count is still stored in memory, and in particular this variable environment has been transferred to the heap in this case. But more on that later. Again, the execution context is gone at this point. But the variable passenger count set to 0. It still lives in the engine's memory. And this is very important to keep in mind moving forward. But most of this is actually nothing new at this point. All we did was analyze the call stack and the scope chain as well. We call the secure booking function, and this is going to be very important to later understand and see the closer. So we didn't see any closer at all we did was using the knowledge that we already have to understand how this booker function was created. But now let's back to our code to actually use the booker function and finally see the closer in action. Now let's now call the function so, and now as we see that it doesn't need any arguments. So there is no list of parameters, right? So let's call it 3 times again. And now we'll just reload. Check the result that we have here the one passenger and the second passenger and 3 passengers. So what this means is that the booker function was in fact able to increment the passenger count to 1, then 2 and then 3. So but now if we think about this, then how is this even possible? And how can the booker function update this passenger count variable? So that's defined in a secure booking function. So that is this, and that's actually already finished executing. And so, as I just said, this function has already finished its execution, it is gone. So, its execution context is no longer on the stack. So, as we just saw in the slide. So, but still, this inner function here which is the booker function, is still able to access the passenger count variable that's inside of the booker function. That should no longer exist, and maybe you can guess that what makes this possible is a closure. So again, this booker function here is simply a function that exists out here in the global environment or in the global scope, and the environment in which the function was created. So this here basically this environment is no longer active. In fact, it is gone. But still the booker function somehow continues to have access to the variables that were present at the time that the function was created. And in particular, this passenger count, that is passenger count variable here. So that's exactly what the closer does. So we can say that a closer makes a function. Remember all the variables that existed at the function's birthplace only. So that is here. And so we can imagine the secure booking as being the birthplace of this function. So of the booker function essentially, and so this function remembers everything at the birthplace by the time it was created. And this cannot be explained, and this is explained with the scope chain alone. So we need to also understand the closure, and so let me know really explain how it actually works. And scope chain after the last slide, and let's now start by remembering that the execution context of secure booking that was popped off the call stack after that function finished running together with its variable environment. Now also remember how we said that this environment which contains the passenger count variable is still stored in memory. But why is that? We didn't learn earlier in the lecture about garbage collection that variables stored in the stack are destroyed as soon as the execution context pops off the stack. Yes, we did because that's really the case. There is, however, one exception that we talked about, and that exception is the existence of a closure. So remember how we said that if an object is reachable by a closure, it cannot be garbage collected and will therefore stay in the heap indefinitely. And this actually applies to objects in the heap and to variable environments for variables that are stored in a stack as long as they are reachable by a closure. Now, in a summary, the passenger counts variable still exists because it is in fact reachable by a closure. That's the only reason, otherwise, it would really be gone. But in this case, the engine moved the variable environment to the heap where it can stay forever. Again, because it's reachable by a closure and can therefore not be garbage collected. So, this is why the passenger count variable still lives on. So the way memory and garbage collection work plays an essential part here. And now I told you in this lecture everything would come together, and so make sure that you understand all the stuff that we learned earlier. And so in this case that we learned about memory management and garbage collection. But anyway, now it's time to finally run the Booker function and see what's exactly going to happen here. And this way note that Booker is really this function here. So, located in the global scope. So, the first thing that's going to happen when we run this function is that new execution context is put on the top of the call stack. And the variable environment of this context is empty simply because there is no variables declared in this function. Now, what about the scope chain? Since the Booker is in the global context, it's simply a child scope of the global scope, just like this. But maybe by looking at this scope chain, we are starting to see a problem. How will the Booker function access the passenger count variable? It's now where to be found in the scope chain of this function, right? So this is where we now start to unveil the magic of the closure. I mean, we already know that the closure exists because we saw it in our code, but we don't really know what it is and why it exists in the first place. So the magic is basically this. Any function always has access to the variable environment of the execution context in which the function was created. In this case of Booker, this function was created, so it was born in the execution context of secure booking, which we popped off the stack previously. So therefore, the Booker function will get access to this variable environment which contains the passenger count variable. So that's the magic trick right there. This is how the Booker function will be able to read and to manipulate the passenger count variable. And so this connection is what we call the closure. So let's say all that again to make this really clear. So a function always has access to the variable environment and so of the execution context in which it was created even after that execution context is gone. And this last part is really important. The closure is then basically this variable environment attached to the function exactly as it was at the time and place that the function was created. And this probably still sounds confusing, but don't worry, I have some more familiar analogies in the next slide. For now, we are just trying to understand the mechanism behind the closure. So how it all works behind the scenes. So what matters the most here is that the booker function has access to the passenger count variable because it's basically defined in the scope in which the booker function was actually created. So the scope chain is actually preserved through the closure even when a scope has already been destroyed because its execution context is gone. This means that even though the execution context has actually been destroyed, the variable environment somehow keeps living somewhere in the engine. Now we can say that the booker function closed over its parent scope or over its parent variable environment. And this includes all function arguments even though in this example we don't have any. And now this attached or closed over variable environment stays with the function forever. It will carry it around and be able to use it forever to make it a big more disgustable. We can also say that thanks to the closure, a function does not lose connection to variable that executed at the function's birthplace. That's a bit more But anyway, let's see what happens now with the execution of the booker function. So the function attempts to increase the passenger count variable. However, this variable is not in the current scope and JavaScript will immediately look into the closure and see if it can find the variable there. So after running this function, the passenger count becomes 1. This message is logged and then the execution context is popped off the stack. Then execution moves to the next line. We get a new execution context and the closure is still there, still attached to the function and the value is still 1. And so now the execution executes increasing the passenger count to 2 and logging a message again. And that's what closures are and how they work behind the scenes. Now let me give you some couple different definitions of closure now, some more formal ones and some more intuitive and maybe easier to grasp. And the most formal definition of a closure is the one we already saw, which is that a closure is the closed over variable environment of the execution context in which a function was created, even after the execution context is gone, or in other words, even after the function to which the execution context belongs has returned. Next, and a bit easier to understand, a closure gives the function access to all the variables of its parent function. So the function in which it is defined even after that parent function has returned. So the function keeps a reference to its outer scope even after that outer scope is gone, which basically preserves the scope chain throughout the time. And another definition, or let's say analogy, is that a closure makes sure that a function does never lose connection to the variables that existed at the function's birthplace. It remembers the variables even after the birthplace is gone. It's like a person who doesn't lose connection in their hometown. In this analogy, the person is the function and the hometown is the function's parent scope. And the function then does not lose the connection to the variable stored in that parent scope. And I hope that this makes sense. Finally, some people link to think of this attached variable environment as a backpack. So in this analogy, a function has a backpack which it carries around wherever it goes. And this backpack contains all the variables that were present in the environment in which the function was created. Then whenever a variable can't be found in the function scope, JavaScript will look into the backpack and take the missing variable from there. So kind of similar to the other definitions, but maybe a little bit more visual. So there are some different ways of defining closure, but they all mean the same thing. So they all represent the same idea. Finally, we need to understand that we do not have to create closures manually And this is also what I already touched on at the beginning of the lecture. So instead, this is something that JavaScript does completely automatically. We don't have to do anything. Also, there is no way for us to explicitly access closed over variables. That is because closures are not like a tangible thing. They are not like an object or so that we can access. So we cannot just reach into a closure and take variables from it. That's impossible because a closure is just an internal property of the function. We can observe that a closure happens because functions magically keep having access to variables that should no longer exist. But we cannot directly access to these variables. However, what we can do is to actually take a look at this internal property and set this backpack to say in the console. So let's quickly do that before we finish the lecture. And we can do this by using console dot write console.dir and then the booker function itself. So here similar to console.log, but this one is a bit different. So now we get this function itself, and so we can get the arguments, the name of the property, and we already take a look at before, and then down here we have the scopes, and this scope property here is basically the variable environment of the booker function. Now in here we can actually see the closure coming from secure booking, and so this is where we you see the passenger count which is currently stands at 3, and so this closure here basically is the variable environment. So this secure booking, that's the one that is being preserved by closure. Whenever you see these double brackets here, that means that it is an internal property which we cannot access from our code. And this was a long video about closure. So in the next lecture, we are going to take a look at 3 more examples of closures and analyze how they work. And so this is all about the closures. We'll see you in the next lecture. Thank you.